Thanks for stopping by our virtual poster on using hand analysis in a digital age. I'm Barb Mays-Bousted. I don't know of any research that quantifies it, but from experience and observations, I can tell you that we look through hundreds of model time step images when making any given forecast. Several models, from initialization to end, at multiple analysis levels, from the most recent run plus previous and incoming runs. By math alone, any given image is only on our screen for a very short time, measured in seconds, not minutes. We look at these under varying levels of distraction as we also answer phones, talk to colleagues, and so on. How much of an image are we really seeing, let alone encoding into memory? So what do you recall from the images you just saw? Where were the 500 millibar trough axis and height falls? At 850 millibars, how far north had the 8 degrees Celsius dew points reached? Let's build an analysis that we can follow more intentionally. Ideally, I would draw this for you here in real time, but technology and time limit it. For demonstration, I'll layer on the digital images of analysis fields. The process of creating these, though, is the cornerstone of the hand-to-brain pathway and not one to neglect. These 500 millibar analyses are hand-drawn in digital software by Josh Bousted, and as a reminder, subjective analysis is just that, subjective. That you do it matters more than how, as long as you can distinguish your features when you're done. We analyze the heights first, drawing in the isohypsis, followed by analyzing height changes. Next, we highlight stronger winds, starting at 50 knots. After that, we consider temperatures. For me, the important feature really is the difference between the 700 and 500 millibar temperatures to visualize the lapse rates. Finally, we add on the positions of highs, lows, troughs, and ridges. Subtle shortwave troughs and ridges can make or break daily weather, so I would be very diligent to try to pick these out, matching them to water vapor imagery for confirmation. In the end, fully analyzed hand-drawn maps can look something like these works of art from Roger Edwards. Just about every forecaster has a different style, a different set of preferences, a different combination of perfect replicas of synoptic class requirements and personal style. In fact, there's even variability among the 4 co-authors of this study. And even so, the major features emerge. The trough in the central U.S. with several pockets of falling heights, and the jet axis across the eastern U.S., for example. By analyzing a series of maps as an event approaches, a forecaster gains an even greater sense of the continuity of the event, how the features are evolving and changing. Roger worked this event and had also done an analysis of 0Z on the day prior to our 0Z example. The analysis also helps identify more readily where the models are getting it wrong in the initial conditions. If your weather event is in the next, say, 24 to 48 hours, those initial conditions become far more important to sort out. Where is the model biased? Too dry or too wet, for example. Let's zoom in more closely to the area in the black box. In this example, the model is overestimating dew points in the area outlined in yellow, while underestimating in the area outlined in the very light pink, due to errors in the position of the approaching low and associated fronts. Hannah Wells has dug into cognitive science publications. Our ability to recall information, and thus to use it, depends on how we encode it. That matters because as you go through your forecasting process, you are trying to recall the initial state of the atmosphere as the starting point for a forecast going forward. Your ability to accurately recall what it was increases if you encode it manually via drawing and handwriting. That could save you from flipping back and forth between images a bunch of times through your shift, increasing your efficiency later in the process. A chunk of research does support paper over screen displays for additional comprehension, but whether that applies to digital hand analysis is unknown. Practice will make the process flow more naturally. The high-impact weather days are when we need a deep fundamental understanding of the atmosphere the most. In this era of blended models and ensemble spreads and means, many forecasters have asked what their role will be. Here it is. Deep analysis and understanding of the current state of the atmosphere, how it aligns with our conceptual scientific understanding, and how well the models resolve it, all supports our ability to translate the weather and our forecast decisions to our core partners and publics. This is where we add value. So give it a try. Let me know how it goes.